All right, we're recording. It says in the directions, you need to know your powers of 2, 3, 4, and 5. If you don't know what I mean by that, all I mean is be familiar with what 2 squared is. 2 cubed, 2 to the 4th, 2 to the 5th, and so on. All it is 2 times 2, 4 times 2, 8 times 2, 16 times 2, and so on. Okay? Powers of 3, 3 squared, 3 cubed, 27, 3 to the 4th, 81, 3 to the 5th, 243. If you don't know them, type them in when you get to one of these problems. Okay? Next, powers of 4. 4 squared. 4 cubed is just 16 times 4. 4 to the 4th is 256, and that's about it. 5 squared times another 5 times another 5. And that's generally good enough. If the numbers are any bigger than that, punch them in. If it's 5 to the 8th, punch in 5 to the 8th, see what it is. Probably won't be. So as you look up at these problems, you want to look between these two. Is 3 and 27, are 3 and 27 in the same power tree? 3 and 27 are. 3 is 3 to the 1. 27 is 3 to the 3rd. Write them that way. 27 is 3 cubed. What's 1/3? What's actually going to take 3 and turn it into 1 over 3? Three to the... Maybe we should continue our tree upward. What's 3 to the 1? 3. What's 3 to the 0? 1. When you get into the negatives, what starts to happen? Doesn't make them negative, it's flipping. It's going to flip them. What's 3 to the negative 2? 1/9. It takes all of these and flips them. 9, 1/9. What do you think 3 to the negative 3 is? 1 over 27. Okay. So, what's 1/3 as 3 to a power? 3 to the negative 1. What's still out here? The x. We're really close. What can we do with an exponent to another exponent? Multiply them. When you have the bases matching and you have an equation, you know what you could say about their exponents? They're equal. And when you divide both sides by -1, you get x equals -3. Check your work. Type in 1/3 to the -3. If it says 27, you did it right. You cancel the exponents and you cancel the bases and let their exponents be equal. Let me just show you that on a separate page. There's a property on your properties of exponents that says this. If a to the m equals a to the n, what's true about m and n? They're equal. That's what I just did on that problem. If the bases match, you could set their exponents equal. The bases matched, so we set their exponents equal. Divide both sides by -1. In problem B, look at the numbers 16 and 32. Are they in the same power tree? Which one? 2's. They're not both in 4, right? They're not both in 4, but they're both in 2's. How can we write 16? 2 to the what? How can we write 32? 2 to the 5th. You see the stuff in parentheses? How can you take that 2 to the 4th, which is in the bottom, and send it back to the top? We're really close. What can we do with these exponents? Multiply them. Now that the bases match, what can you do with the bases? And you cancel them out, and the exponents just drop down, and you have a simple equation from 5th grade, maybe 6th. If negative 4x equals 5, what do you do to get x by itself? So x equals negative 5/4. Try it. Check your work. Type in 1/16 to the negative 5/4. If it says 32, you did it right. Make sure you put 1/16 in parentheses.